Hello everyone. In this video, we are going to discuss about single linked list in data structures. This is the outline of this video. This video consists of an introduction to linked list, abstract data types, that is various operations that can be performed on a linked list, is a C program, advantages and disadvantages of linked list. Before starting this video, please like the video, subscribe to our channel and hit the bell button. Then only you will receive a notification whenever a new video is uploaded. So this video will be somewhat lengthy. Now let us start what is meant by linked list. A singly linked list is a fundamental data structure. It consists of nodes where each node contains a data field and a reference to the next node in the linked list. So in a single linked list consists of various nodes where each node consists of two different fields. First field represents the data, whereas second field represents the address of the next node. The next of the last node is null. So this is the last node. It consists of two fields, data field and an address field. The address field of the last node will be null because there is no corresponding node to the last node so that it can show the address. So this will be null. Linked list support efficient insertion and deletion operations. Now let us look what are the abstract data types of the linked list, single linked list. The abstract data type are the various operations that can be performed on a linked list. A single linked list performs creation operation, display, insertion, deletion operations, search and reverse display operations. Now let us understand each operation in detail. So let us look what is meant by creation operations. In a single linked list, let us consider we created a single linked list with three nodes. Let us consider the first node has the address of 500, second node has an address of 1000, whereas third node has an address of 2000. As we know that the single linked list consists of two fields, data field and an address field. The data field we will scan the element and the address field corresponds to the address of the next one. So here the second node has an address of 1000. So in the first node we will have 1000. Similarly, the third node has an address of 2000. So this 2000 is the address in the second field. Similarly, the third field is the last field. So it will be null. Similarly, we declare two variables, start and last. Start corresponds to the first node, whereas last corresponds to the last node. So this is creation operation. Now let us look display operation. In display operation, we start with the starting node and we will display the elements until we reach to the last node. This is meant by display operation. Now the third one is insertion operation. Let us consider we have three nodes of data 10, 20 and 30. If we want to insert a node 15 at position 1. So now the 15 has let us consider the 15 has an address of 800. Now the updated list will be starting node has an address of 800 that corresponds to the second node, whereas the second node has address of 1k which corresponds to the third node. The third node and the fourth node will be unchanged. So this is meant by insertion operation. Observe the address changes. We will uh, we will understand clearly in coding part. Now let us look deletion operations. So in this linked list, if you want to delete an element 20, then we need to update the address of its previous node, because consider this second node, it has an address of 1k corresponds to the 20. So deleting 20, the address 1k should be changed. That is, address of 20 should be shifted to the address of its previous node 1k. So after deleting, we will have an elements 10, 15, and this will be 30. 10 has an address of 800, whereas 15 has an address of 2k. And the last node will be null, has an address of null. So this is the deleting operation. Now searching operation. Suppose if you want to search an key element 30, we will start with the starting element and we can move to the corresponding element through its link. So while the corresponding element is equal to null, we will keep on searching the elements. If the element is found, we will return its position. So this is searching for in a linked list, single linked list. Now say similarly reverse display. We start with last element. We will display the elements until we reach to the first element. So these are the 6 operations that can be performed on a single linked list. Now let us write a C program in a C compiler for a linked list. So this is the main function. The type def structure node consists of two fields. First one is data field and second one is the address of the next node. We represent it with data and link, and we declared another 3 variables in the before the main function: start, last, and next. The start is initially initialized to null. Int n stands here n stands for the total number of elements. So in the main function, we declare the 6 functions: create, display, insertion, deletion, search, and RDSP. Delete, search, and RDSP. So in the main function, we are running a while loop. In the while loop, first initially we will prompt an output consisting of these. So if we enter element 1, then it will create operation. If we enter element 2, it will perform display operation. Similarly, 3 for insertion, 4 for deletion, 5 for searching, and 6 for a reverse display. 7 means we will exit from this code. So while entering this choice between 1 to 7, here 1, in which case we use we are using switch case to perform the operations. One stands for create, and similarly for remaining functions. So whenever we enter one, we are calling create function. So when calling this create function, it will come into this function create. So now let us complete these 6 functions of this linked list. In the create function, so this is the creation function. Initially we initialize start to null. We are scanning the total number of elements using n. So for int I is equal to 0, I is less than n. So this for loop runs up to n number of times. Suppose we are having 5 elements, this for loop will run up to 5 times. So in that loop, as we said earlier, the single linked list consists of a node consists of 2 different fields. First one is data field and the second one is address field. So the 2 fields are created using malloc function. Node star malloc size of node. The size of node is 2. See here, size of node is 2. So this temp consists of 2 empty fields. In the first field, we are scanning temp of data. We are scanning the data, and the temp of link, that is address field, is set to null. So in the first iteration, the start will be null. So if start is equal to null, start is equal to temp, and next is equal to temp. So if we are inserting a 10, 20, and 30, in the first iteration, we are scanning temp of data to 10. Then start will be at 10, next will also be at 10. So in the second iteration, if you are inserting, if you are creating with 20, start is not equal to null. So it will fail if condition in the second iteration, and it will perform else condition. Next of link is equal to temp, and the next is equal to temp. So this is the this is the logic for creating a single linked list. Now let us perform display. So this is the display function. If start is equal to null, we are printing that list is empty and returning. So if start is not equal to null, initially we are setting temp to the start. While temp is not equal to null, we are printing that temp of data. So the temp passes through temp is equal to temp of link. Suppose the 10. So this is the logic for a display. Now let us look for a insertion and deletion. So this is the logic for the insertion function. Initially we are declaring POS stands for position. Enter position to insert. If position is less than 1 or position is greater than number of elements plus 1, then we are printing that position is out of range. Again, after entering a valid position, we are creating a node using a malloc function. So remember this function for creating a node. We are scanning the value to insert. Next is a pointer variable. We initially declared it start, next, and temp. So that next is a initializer to start variable. If we want to insert at the first element, then temp of link is equal to start. The temp is newly created node. The address of the temp variable is start, and start is again reinitializer to temp. So if you want to insert other than position 1, then we are using this next pointer variable. This next will be at position -1. So temp of link is equal to next of link. The temp of address will be of next of address. Next of link will be temp. And finally, we are printing %d inserted successfully and increasing the number of elements count. So now let us complete a deletion, search, and reverse display function. So this is the logic that is used for deleting. Here ELM represents the element that is to be deleted, and we are initializing flag to 0. So if element is equal to start of data, which is starting element, then we are initializing temp to the start. Start is equal to start of link. That is, start consists of an address corresponding to the next node. The start will be passed to the next node. Here free of temp is used to delete the corresponding node. So if element is not the starting element, it comes into the else function. Here next is equal to start, while next of link is not equal to null. That is, we are traversing it until the last element. If next of link of data, that is the corresponding data is equal to element, then we are allocating that to the temp. Next of link is equal to temp of link, and finally free of temp. Here we are incrementing flag value because if the element is not found, flag will be 0. If flag will be 0, we are printing that element not found. So this is the logic that is used for deleting. Now only two functions left, search and reverse display. Let us perform those. So this is the logic that is used for searching the function, searching a key element. Initially we declared key, position is set to 0, flag 2 is set to 0. So temp is equal to start. Temp is a pointer variable. It corresponding to the starting element. So we are scanning the key element that is needed to be searched, while temp is not equal to null. And that means we are traversing until the last element, from first to last element. Temp is equal to temp of link. So if that key value is equal to the temp of data, we are printing that position, I mean that key element is found, and incrementing the flag value. Similarly, we are incrementing the position for each iteration. So this is the logic for searching function. Now only one function is left, that is reverse display. Let us complete that. So this is the logic for the reverse display function. We are using a recursive call for the reverse displaying the elements. So these are the various functions or various abstract data types that are performed in a single linked list. Now let us execute this code. this is the updated code. Initially I initially I did not use ampersand variable here. Scan of %d ampersand temp of data. So let us execute once. Enter your choice. Create. Enter the range 5 elements. 10, 20, 30, 40, 50. These are the 5 elements. List is created successfully. Let us display that list. See, updated list is 10, 20, 30, 40, 50. Creating is successfully done. Displaying is successfully done. Now let us insert. 3. Enter position to insert. I will insert it position number 2. Enter data to insert. Let us insert 25. 25 is inserted successfully. Let us check once. See, 10, 25, 20. So 25 is successfully inserted. Now let us perform a deletion operation. Enter element to delete. 20. 20 deleted successfully. Let us display once. See, the updated list is 10, 25, 30, 40 and 50. So these 4 operations are successfully done. Now let us perform search operation. Enter key value to search. Let us search for 70. 70 not found. Let us search 30. See, 30 found at position 2. 0, 1 and 2. 30 is found at position number 2. And finally we are let us use reverse display function. 50, 40, 30, 25 and 10. Reverse display is successfully done. Now we will exit out of the code. So this is the C program for the single linker list. Now let us look what are the advantages and disadvantages of single linker list. It has a dynamic size, no fixed limited like array. See, array means contiguous memory locations. That is, the memory is allocated subsequently. Here address is 100, 101, 102 like that in arrays. But whereas in linked list, it has dynamic size, dynamically allocated. The second advantage is efficient insertion and deletion at beginning and end. We also have insertion at the middle efficient if we have a reference or a pointer to the node after which we need to insert. So inserting the element in the middle of an array is difficult, but inserting an element in the array, inserting element in the linked list is simple. Can implement complex data structures like stacks, queues, graphs, etc. These are the advantages. Now let us look about the disadvantages of linked list. Extra memory required for storing pointers. See, in this program we used 3 different pointers: start, next and last. So some of the extra memory is needed. No direct or random access. It needs traversal. It is cache unfriendly. It is not stored in contiguous memory locations. This is the difference between array or a linked list. And these are the advantages and disadvantages of the linked list. So this is about this is in this video. Thank you for watching till the end. In this video we discussed about introduction to linked list, abstract data types, C program, and advantages and disadvantages of linked list. So thank you for watching this video. Please like, share and subscribe. If you have any doubts or feedback, please comment below. Thank you for watching.